I'm back again. So this video is about rhombuses, and rhombuses actually have two extra properties compared to parallelograms that you might not be aware of. And hopefully that Geometer Sketchpad sketch really helped you understand what a rhombus was. Shaped like a diamond, and remember, a rhombus is a parallelogram with all four sides that are congruent. So all of these properties also pertain to a square too, because a square fits that definition. And the biggest thing is that you have to recognize it's all about angles for rhombuses. Rhombuses don't have really anything to do with sides other than these sides being congruent. It's all about the angles. And the first thing you need to do is the diagonals are perpendicular. So that's the first property. That means that where they intersect, it's a right angle. So all of these are right angles. And that also means that all of these triangles are right triangles. And that comes in handy. And the diagonals bisect what I call these vertex angles. So at M, there's two little dashes here, right? There's one swoosh and then one swoosh. That means that if this is 20, this is 20 on either side. R has two little swooshes. So if this is 20, these are 20 here, okay, these could be 70 and 70. They're all going to be split in half at the vertex, at the corner of the rhombus. And that is the second property of rhombuses, or rhombi, is that these vertex angles are bisected. They're cut into two equal parts. So to get a little practice at this, okay, example 1 here. It gives you this angle BAC, this angle right here is 32 degrees. The first thing I can label here is this 4 is 90 degrees. So angle 4 equals 90 degrees. Where those diagonals bisect, that means that's a 90 degree angle. Well, if that's a 90 degree angle, then that's a 90 degree angle, right? So there's multiple right angles here. I also can say, oh, this right here is a triangle. And I have 90 and I have 32. So I can do 90 plus 32, get 122. Take that and subtract from 180. And I get a grand total of 58. So angle 1 is 58 degrees. If angle 1 is 58 degrees, angle 2 has to be 58 degrees. Because this diagonal bisects those. So angle 2 equals 58 degrees. And I can just work right around the figure. Okay, if that's 58, that's 90. Well, these triangles, they're the same.
Excuse the interruption. These Hartford South students may now be dismissed. These Hartford South students may be dismissed.
This is 32. And if that's 32, then angle 3 has to be 32 degrees. So you're dealing with some right triangles, and then once you have the math done on one right triangle, they're all going to be the same all around the figure. So for problems 3 and 4, we're using the same figure. And I'm going to skip to 4. Find the measure of angle CEB. CEB. That's this angle right here. That's the easiest question in the world, because these diagonals are perpendicular. So that measure equals 90 degrees. That is always the case. So this is a right angle, these are right angles. Only if it's a rhombus. Now, the next thing is AB for number 3 is 26. And then they say BD, this length, is 20. That whole length is 20. Now, this involves you remembering back to a rhombus is a parallelogram. So, if this whole length is 20, this individual piece is 10, this individual piece is 10, so that's the whole length. And now what I have to do is I have to solve this right triangle. Okay, so if you can't see it, there's a right triangle right there. And I'll draw it over here. 10, the right angle. Oh, I don't know that, but oh, AE. That's what I'm looking for. That's my X. And my hypotenuse is 26. So what I have to set up is a squared plus b squared equals c squared. And you're going to find that with rhombuses because of all these right angles. So then a squared is going to be x squared plus b squared, which is 10 squared, equals c squared, which is 26 squared. So then I square them. X squared plus 100 equals 676. I subtract 100 from both sides. I get x squared equals 576. I then take the square root of both sides. And the square root of 576 is 24. So that length right here is 24. And that's what I'm looking for. So you gotta remember Pythagorean theorem. For this next example, we have, again, angle skip. Okay. So the first thing, this is a rhombus, so I'm going to label some right angles here, because those are all right angles in there. And now I'm going to label the angles. CDB is 6y. ACB is 2y plus 10. What I can do is I can take these and I can just label their partner, because this is bisected. 2y plus 10. If that's 2y plus 10, this angle has to be 2y plus 10. Now, I have angles in a triangle. And I know that angles add up to 180 degrees if they're in a triangle. So, 6y plus 2y plus 10 plus that 90 equals 180 degrees. I can combine like terms on this side and get 8y plus 100 equals 180. Subtract 100. 8y equals 80. Divide by 8. Y is 10. So you have to apply the algebra and then solve using some geometry concepts of triangles adding up to 180. The next ones deal with proving something is a rhombus, a rectangle, or a square. And it might sound difficult, but again, it's all about slope. So the first thing is to plot the points and then label. A, B, C, and D. Now, if it's a rhombus, these lines are going to intersect at 90 degrees. And I can check that by doing, okay, B to D, that's a straight vertical line. A to C, that's a horizontal line. So I know they're going to intersect at 90 degrees. So, to check for a rhombus, find the slope of the diagonals. And if they're opposite reciprocals, so if they're opposite reciprocals, that's a check. That's a yes. It's at least a rhombus. Okay? In this case, horizontal and vertical, they are perpendicular. So that is a rhombus, so I'm going to check that one off. So I've just proven that it's a rhombus at least because of these perpendicular diagonals. So what I'm going to do is, now I'm going to talk about what it means to be a rectangle. Well, a rectangle, I have to find the slope of the sides. And if the sides are opposite reciprocals, then it's a rectangle. So, the biggest thing is just going from left to right and counting. So, 1, 2, 3, 4, 1, 2, 3, 4. So the slope here is 4 over 4, or 1. I can also do the same thing from A to D. 1, 2, 3, 4, 1, 2, 3, 4. So down 4 over 4. Well, down 4 over 4 is negative 1. That means that at least those two sides are at a right angle. And I just finished it off by finding these two slopes. 1, 2, 3, 4. 1, 2, 3, 4. So this line has a slope of 4 over 4, which is 1. And this has a slope of negative 4 over 4, which is negative 1. So each one of these sides is an opposite reciprocal. So it is a rectangle. And if it's a rhombus and a rectangle, then it's a square, because it fits both of those definitions. Now for others, it's not going to fit that definition. So if I check this for a rhombus, okay, I have to check, okay, is A to C going to be an opposite reciprocal of B to D? Even just looking at those lines, I can tell this is not going to be a 90-degree angle. But A to C, I'm going up nothing, so that's 0 over 1, 2, 3, 4, 5. So A to C, the slope is 0 over 5, which is 0, meaning it's a horizontal line. B to D, I can count 1, 2, 3, 4, 1, 2, 3. So down 4 over 3. These are not opposite reciprocals. So rhombus is out. That means if it's not a rhombus, it's also not a square. But I can check for a rectangle. So A to B is 1, 2 over 1. So A to B is 2 over 1. A to D, 1, 2, 1, 2, 3, 4. Down 2 over 4. Down 2 over 4. Well, that's negative 1/2. Those are opposite reciprocals. And then I can check B to C. 1, 2, 1, 2, 3, 4. B to C is again that negative 2 over 4, which is negative 1/2. And D to C is 1, 2 over 1. So D to C is 2 over 1. That means that there's a lot of opposite reciprocals. So this figure in here, and you could probably tell by just graphing it, is a rectangle. Because the sides are at 90 degrees, but the diagonals are not. And that's how you prove something is a square, rectangle, or rhombus. So please try the rest of these problems and come in next class with any questions you have.